And what are the layers, what are the parts of the fibrous?
Cornea and the sclera.
Cornea and the sclera being the white part, okay. And then the next layer inside is the vascular. And what does it have?
Mirrors.
Starting from the front, going back. Iris. The ciliary body and the choroid, okay? And since we have sheep that we use, it had a special adaptation. This looks like a sheep eyeball right here. It's oxeye. It's similar. It has a special adaptation called the
Mother of pearl.
No, that's not what it's called, mother of pearl stuff. It looks like mother of pearl, but what's its name?
Tapetum lucidum.
Tapetum lucidum, okay? And it's for animals that have to see in dim light, okay? And it's vascular, obviously, from the name you can tell, the choroid. And it helps nourish the next layer the innermost layer, which is the neural, which has the retina, okay? And then we have fluids in here. In front of the lens, we have the
Ligaments.
aqueous humor.
I'm sorry.
Aqueous humor, okay, which is very watery. And it's made where?
Ciliary process.
The ciliary processes made from blood, and it's reabsorbed where? Canal of Schlemm. Also known as a sclerovenous sinus, okay? And if that doesn't get absorbed and it builds up, that increases what we call the intraocular pressure, and that can lead to a condition called glaucoma. And why is that bad? It can make you go blind, and it's very secretive at first. It doesn't let you know you have it, and that little puff of air is how you find out. And it can displace the lens and do all sorts of stuff. Okay. What about the fluid back here behind?
Vitreous humor.
Vitreous humor, kind of jelly-like until you get it out, and then it liquefies. And does that turn over? No. But it's useful for forensics because you can't get other fluids like urine or blood. I've seen them go in and take a little sample out of the eye. But it doesn't hurt if you're dead.
People watching.
Yeah, and I couldn't believe my students didn't notice it. I noticed it because I was expecting it to. I thought it was going there. Okay. So let me get the picture book over there, the blue. Yes. Okay. Okay. We have several muscles coming in from the outside. They're called extrinsic muscles coming from outside, and we have 3 cranial nerves that help with the eye movement. Okay. What's the major one for eye movement? Ocular motor, which means eye mover. Okay. It also has some other special duties. It's parasympathetic for 2 muscles inside the eye. Okay. So,
And it's just the eyelids.
Oh, okay. So it has lots of little jobs. It's a busy little nerve. So what muscles does it control? Superior rectus. Medial rectus and
Lateral rectus.
inferior rectus and inferior oblique. Okay. The superior oblique is controlled by what nerve? Trochlea. Remember, trochlea means pulley, so it's like a pulley thing. And what's the last one? Abducens, which is for the lateral. No, not inferior.
Lateral is rectus.
Right. You didn't say that. You were saying inferior. I heard you. Lateral rectus. Abduction, right? Abducens. Abduction. Okay. And then inside the eye, we have some muscles too. We have within the ciliary body, we have the ciliary muscles, which are circular muscles. When they contract, they actually loosen ligaments that are attached to the lens, and by loosening the ligaments, the lens gets fat. Okay. And you do that when you look at things up close. Okay, so this is parasympathetic type of function. So when you're looking at things up close, a lot of the light rays are diverging. So we have to have the lens fatter to make them converge again to hit the retina at the right place.
And a smaller hole.
Huh?
And a smaller hole.
And we have a smaller pupil. Not hole.
It looks like a hole to me.
It is a hole, but it's called a pupil, a special hole, because we have many holes in the body, right?
Orifices.
Okay. So we have the, huh?
Nothing.
Okay, don't let you start. Okay. So we have sphincter muscles on the inside that make the pupil smaller under the control of
Parasympathetic.
parasympathetic, which nerve? Ocular motor. Okay, that gets rid of a lot of those diverging rays. So you get rid of, you're getting more of just the parallel rays coming in. Okay, and to make the pupil larger, that would be what part of sympathetic? That would be sympathetic. Okay, and then those are the dilator muscles. Okay. So when you look at things up close, the ocular motor makes you use the medial muscles, medial rectus muscles. Pupil gets smaller, lens gets fatter. Okay. So I like to think of, for the parasympathetic, just think of, you're sitting there and you're reading a sad book and you're munching on popcorn or something. Actually, even more appropriate is if you were sitting on the toilet. Okay. Salivation, lacrimation, urination, digestion, and defecation. So that's not a very pleasant picture, maybe I'll have to remember. Slud, yeah. Okay, let's see, what else do we have here? So when you look at the eyeball, remember around the pupil, there's a flat black area. What is that? No, find it there. The flat black area just around the pupil would be what? No.
Just the plated ones. Or pleated.
Pleated. They're right around the pupil. What's around the pupil? Iris.
I was going to say that.
Okay. Iris. And then the pleated black portion is the ciliary body. Okay.
What's around the hole?
The hole. Yeah. Okay. Now, when you cut open the eye, one of the problems is that the fluid came out, the vitreous humor. Vitreous humor is helping to hold that retina against the choroid. Okay, so when you lost that, many times the retina detached, and that with that sort of filmy whitish colored stuff. It's sort of like tissue paper. Sometimes it did, sometimes it didn't. So you can see that in here. That white, well, it's hanging down there. That whitey stuff. Okay, that whitey stuff hanging down is retina. Okay, so let's look inside the eye. And you should look at pictures. Okay, so here's that whitey stuff, that's the retina.
Yeah.
Okay. If we look in some places, we have many layers, okay? The light comes in, and the weird thing is, it goes past through several cell layers to get to the photoreceptors. This is the photoreceptor cell layer here, okay? Sure.
That's the pigment, right?
No, this is the rods and cones.
Okay.
Okay. Then there's a pigmented outer layer. Okay. And beyond that would be the choroid, and then beyond that would be the sclera. Okay. So you have to get through these several cell layers to get to the rods and cones. Rods are for vision in
Dim light.
Cones are for vision
Color.
in color and visual acuity. And when you look at things, you tend to make the light shine, especially on this part right here called the fovea centralis. This is where we have lots of cones and not many rods. So the rods are more towards the periphery. So at night, if you're looking at something, you shouldn't look at it directly. I can't do that myself. Now, once you stimulate the rods and cones, and what color cones do we have? Well, most people, normal
Red,
people.
blue, and green.
Three primary colors.
Normal people. And if you want to, we can use Christopher here as example of color blindness, okay? So we can have lots of fun there, if he doesn't mind.
So you found something you can get at me with.
Yeah. Oh, there's lots of
And
things.
you'll never let go.
So, from the rods and cones, we go back to the bipolar cell layer, which you see here. From that, we go to the ganglion cells. And watch out, this shows a lot of ganglion cells. In our slides, I don't see many ganglion cells. So it's a lot less cells, but that's the ganglion cell layer. And those axons of those ganglion cell layers leave the eyeball as the optic nerve. Also, and that area where it leaves is called the blind spot or
Optic disc.
Optic disc. Pardon me, I have allergies. I hope it's not a cold. I just took a pill, so let's see. I'm doing better. I was sneezing. I hate when I'm driving and have to sneeze. Okay. And there are other cells here too that I didn't go into, but they actually start processing the information even before it leaves the eyeball. Then we have a lot of accessory structures too that you should maybe look over. But here you can see the flat black area, right? The iris, and then the pleated one is cornea. Okay.
Iris.
So not everything goes over, and the pupil is a part that can change shape. So when light comes in, it's first bent by the cornea, then by the
Aqueous humor.
aqueous humor, then by the lens, then by the
Vitreous humor.
So it's the lens that can change shape, and then of course we can see the size of the pupil. Okay. And if you are nearsighted, it's likely that you have an extra long eyeball. The light's focusing too far in front. If you have farsightedness, nearsighted is called myopia. If you have hyperopia or farsightedness, you have probably a short, little stubby eyeball, although the cornea can make a difference too. And if you have uneven cornea or uneven lens, that's called astigmatism. If you're old like me, you probably also have presbyopia, which means old eyes, which means you cannot change the lens shape as easily. You have trouble looking at things up close, although I can look at things real close. I'm so nearsighted, I guess. But it's a lack of accommodation.
What's the name again? Farsightedness is
She's near.
Hyperopia. And emetropia is normal. 20/20. 20/20 vision means you can see at 20 feet what a person with good, eyesight can see at 20 feet. 20/15 means it's better than normal. You can see at 20 feet what a normal person has to be 15 feet. I don't know what I am, 20,000 or so. I don't know.
Short eyeball.
I have to be very close. What did I leave out on the eye? Is that most of it?
So the photoreceptors, are they a neural cell or are they a...
Well, they're receptors. So they're sort of the beginning of the circuit, but they're not considered neurons to be saying, I don't think.
Okay.
The receptors are part of the beginning part and some receptors are part of neurons, like the bare dendritic endings for pain and temperature. Okay.
Olfactory.
Olfactory ones too are neurons. Okay. I don't think these are called neurons. I think they're just called receptors.
But they're in the neural layer. Sure.
Yeah, they're in the neural layer. Okay. So, and then the optic nerve comes out the back like so. And can you know happens here? Do that too.
The medial portion of the eye crosses over.
Okay, so you're going to have the eye.
Okay, creative.
My fancy eye, right? We're looking down on the eyes, okay? So the fibers that are medial, they come across to the other side. The ones that are lateral, stay lateral. And where am I going to right here, by the way?
Optic chiasm.
This is optic chiasm here. This is called the
Optic tract.
no.
Nerve.
Optic nerve. This is called the
Optic tract.
okay.
My bad.
Back there. Okay.
You know who it was.
Then we have this. You think you can hide behind that?
No, I'm getting my camera on here.
Okay, what lobe is back here?
Occipital.
Occipital lobe, okay. We also have little pathways going off to the superior nuclei for visual reflexes. Okay.
And the thalamus, right?
This is the thalamus, right? This is where they so if you cut here, you're listening from which eye?
Peripheral.
Eye. Cut here?
Both.
Both. The right side of both eyes, which would be something coming from the left. Okay. If you have a pituitary tumor,
Peripheral.
you're losing your peripheral vision because the peripheral vision that comes into that part of the eye. After, once you're in the optic tract, you're facing the same side, so same effects. Okay. All the way through. Everybody got that? Pretty good at that, huh? What are you doing, sir?
It's my tripod. I put it.
Okay. Third eye.